All right, so now we're going to continue on with our theme of solving absolute values, but now we're going to introduce inequalities into the equation. I guess it's not an equation, it's an inequality. So, same steps, many of the same steps are going to be involved here. The first thing we're going to do is isolate the absolute value. If you divide by a negative, you need to flip the sign. Now, the absolute value cannot be a negative. It cannot be a negative, okay? After we realize that, we're going to write two equations. Plus, flip the inequality sign for the negative answer. And then we're going to solve both equations. Now we need to go through some considerations for graphing. If your graph's solution is in the middle, it's called a conjunction. And we use the word and. Okay? And by the solution, I mean your x value. Okay? If your graph's arrows, if your graph goes outward direction, it's called a disjunction. And we use the word for. I'm going to explain this as we go through the secondary part later. So, let's go through again, same situation on how to solve this. Our first thing is we're going to try to isolate our absolute value function. There's nothing that we add or subtract to the absolute value function, so we're going to start off by dividing by -3. Since we are dividing by -3, we need to do two things. One, divide by -3. That's going to leave us with the absolute value of x minus 2. But we are also going to have to flip our sign. So our greater than or equal to becomes less than or equal to. And then -15 divided by -3 becomes +5. Now we come to the step where we need to write two equations. By the way, that's equal to a positive, so we can continue to do this. When we write our two equations, we're going to have x minus 2 is less than or equal to 5. And then we're going to have x minus 2 is now greater than, and I want to do this in a different color, x minus 2 is greater than or equal to -5. Notice we flip the sign. Okay? And that's kind of consistent if you think about it. If we go from a +5 to a -5, and something typically we do is we flip the sign. Now we're going to solve for these inequalities, add 2 to both sides, and guess what? On the other equation, we can add 2 to both sides, and we're going to get for one of our inequalities, and I should use the word inequality rather than equation, I'm going to get x is less than or equal to 7. On the other side, I'm going to get x is greater than or equal to -3. Let's go ahead and graph these. I see that this is going to be a closed circle. This is going to start at 7. And it's going to go to the left because I'm looking for values less than 7. To graph this one, x is greater than or equal to -3. This is in closed circle as well because of the underline. So it's a closed circle. I'm going to start that closed circle at x equals -3. I'm going to have my arrow go to the right. Okay? So to state the solution in inequality notation, I notice that my solution is between -3 and +7. X is between -3 and +7. Okay? Between -3 and +7. It's also going to include -3 and 7. So, I'm going to start off by writing my boundaries here. -3, 7. Okay? And since my solution x is in the middle, it's a conjunction. And -3 is going to be less than my value of x. After all, I see that all these values of x, negative 3 is the smallest, so it's less than or equal to. Oops, forgot to put the less than or equal to component there. And then x is going to be less than or equal to 7. At any given point, x is going to traverse on values less than or equal to 7. And that's how I'd write my solution in inequality notation. Okay? Or I could use the words, I could also use the words, x is between and including negative 3 and 7. Okay? All right, that's an example of solving absolute value inequalities. If these were not a conjunction but a disjunction, I'll show you that example real quick before we go on. So let's say for some reason I had this. This would be a disjunction, and I would write this as x is less than or equal to negative 3, or x is greater than or equal to 7. With or being in the middle there, the arrows pointing away from each other, and that'd be a disjunction. Okay? So this would be more of a what-if situation. It's not related to that example specifically, but if this was a disjunction, this is what our graph would look like, and this is how I would state the solution in inequality notation. Go ahead now and work on some more examples.